Okay, here's another example of a reaction mechanism type problem. So we've got our reaction here, 2SO2 plus O2 gives 2SO3, and we've got the rate equations being K, SO2, and O2. So the first thing is, based on this information, can you say whether the reaction is one step or more than one step, and why? And the answer is no, because not all the reactants are in the rate equation. I know some of you are saying, well, hang on, you've got SO2, you've got O2, I've got SO2 and O2, but you need two SO2s involved in the rate equation. I don't see them there. All I see is just a 1. So there's no way that this is going to be just one step. I mean, think about it this way. You've got SO2 and O2. Where's the other SO2 going to have to come in? It's going to have to come in some other step. Alright, so what would it look like if it was one step? Well, it would be SO2 squared and O2. Rate equals K, SO2 squared, O2. And that would be our rate equation if it was one step. Alright, so our next mission is to actually figure out what the reaction processes look like. And the first thing I want to do is draw out my product. And it's 2SO2 plus O2 gives 2SO3. And we know that everything's going to have to add up to give this. That's why I write it out first. Now the next thing I want to do is figure out whether or not the slow step is going to be the first step. And in order to do that, I look at the rate equation and I want to see whether or not I can pull everything that's in the rate equation from the actual reaction itself. I've got SO2, yep, I can pull that. O2, I can pull that as well. So both of those things can be pulled from the reaction, which means I can make the first step the slow step. Then I've got to come up with some kind of products. I know that's going to be slow. I'll write that in. Come up with some kind of products that I can react down here. Now, as I've said in the past, what you should be able to do is, if you can, you're not able to do this all the time, but if you can, see if you can actually make one of the products or the product out of your actual reaction. So I see I've got SO2 and O2. I could actually make SO3 out of that. And if I do that, what am I going to be left with? I've got the S covered, I've got 4 oxygens here and only 3 here. That means there must be an extra oxygen left over. So that would be one way of doing this. So we've got SO3 plus O. Now since the O is not part of this final reaction, I'm going to include it over here because I know it's going to have to react with something else. Then I've got to ask the question, well, what's it going to react with? Okay, so the O2 is covered. I've got one of the SO2s covered here. And I've got one of the SO3s covered here. So what I'm going to do is I'm going to say O plus SO2. And that will allow me to get my second SO2 into the action. And, not coincidentally, it creates SO3 as a product. And there's my second SO3 as well. And that would be fast right there. Alright, so again, what's important is that we figure out that the slow step is indeed the first step because the SO2 and the O2 could both be pulled from the initial reaction, meaning that I could just make the slow step the first step. And remember, anything that you form that doesn't end up in the final reaction must end up as a reactant in some other step so you can get rid of it. Also, try and form the product. If you can do it, form the product out of your reaction.